welcome to our first virtual meetup. I'm missing my beard and my hair, but I promise I'm still the same person. So I want to thank Dashlane for sponsoring our webinars. And today as usual, if anyone wants to join our organization, anyone wants to do any suggestions on topics for talks, we can try to find speakers. If someone wants to give a talk, we welcome first-time speakers. We can mentor them. We can help with reviewing slides. We can help with selecting teams for the talk. So approach us, let us know in which way we can help you, and we will do our best. And join our Slack. If you have any questions, so this is a new format. So if you have any questions, there's the chat option, and there's the Q&A, and there's also the possibility to raise the hands. So any questions that you want to do to the speaker, you write in the Q&A. If there's something pressing and context relevant, you can also click on the button to raise hands, and we will try to get the speaker to talk with you at that time if the speaker feels that they can stop at that moment. And I think that's regarding how it operates. I think that's all. So today we have Tony OREGLIA from Dashlane. He will be giving us a brief introduction to ECMAScript, which I hope everyone knows is the organization that defines the spec for JavaScript and all the debates, all the new additions that come into JavaScript. But he will explain to you better than I can ever do. And then we have JOÃO talking us about the Vega ecosystem for charts visualizations and data visualization. All right. So I'm gonna let Tony share his screen and start. Thank you.
How's that? Can you see the presentation?
Yes.
Yeah.
Cool. So yeah, thank you. Thanks for the introductions there. My name's Tony. So yeah, as Zay introduced, I wanted to share a little bit about, well, really I wanted to share a few of the features that are being considered for the next iteration of JavaScript and future iterations of the ECMAScript specification, and then really to set the stage to look at those new features. I wanted to just briefly introduce the different groups and processes that go into the evolution of JavaScript. And yeah, I think the features are the more interesting part of the presentation, but maybe the groups and processes might be the more important part to understand, because knowing this gives us, empowers us to get more involved in the evolution of JavaScript, and knowing what the groups are and how it all works and how it changes gives us a chance to find ways to get involved and hopefully influence the future of JavaScript. And I think the more involved all of us, like the coders on the front line, get in the process is a good thing. So just quickly, the agenda. So a very brief history of JavaScript, just to set the stage and context. Then I'll explain or give a refresher, because we don't always think about these organizations. What is ECMA International? What is ECMAScript referred to specifically? And what is Technical Committee 39? And then I'll jump into the interesting part of the presentation, some of the upcoming proposals and with some code snippets and explanation of what each of those are. And then I'll give a little bit of advice, actually taken directly from Technical Committee 39, regarding how to get involved in the process and different ways that anyone can get involved and contribute. And then discussion and questions if we have any. So yeah, my name's Tony. I code at Dashlane. I like camping and chess and many other things, but those were the first icons that came up. So yeah, so where it all started, this is the man himself, Brendan Eich, the creator of the original JavaScript implementation, and that was all the way back in 1995. It was originally called Mocha, and then LiveScript, and finally JavaScript. And it was named JavaScript in 1996 when it was announced. So the next thing that happened is Netscape met with ECMA International because they wanted to create a standard for JavaScript to encourage multiple implementations. Sorry. And so, yeah, for those that don't know, or just a refresher, ECMA International, it's an association. It was founded back in 1961, and it's just an association dedicated to standardizing information and communication systems. And they do this for many, many different technologies. So if you actually go to the wiki, this is obviously just a small excerpt from the wiki, but you can see there's hundreds of different standards that they are responsible for. Like you can see that 8-inch floppy disk standard there, just to give you an idea of how much past and present they've been responsible for. So after, so in 1997, ECMA 262 was adopted, and this is what we refer to as ECMAScript. And this is the standardization for, well, it's a standard language. And JavaScript happens to be the most common implementation, but there are others out there. And so you can see they came out with ECMAScript 2 in 1998, 3 in 99. ECMAScript 4, they skipped because there were some disagreements that they were not able to resolve. But since 2015, they've been coming out with a new ECMAScript release every year. So yeah, as I said, ECMAScript contains the specification for a general purpose scripting language. JavaScript just happens to be the most popular implementation today. If you do take a chance to look at the standard, there's a link here. So I'll share a link to this presentation afterwards. And yeah, it's very comprehensive. It has almost everything. For someone who's coding in JavaScript, it's all, of course, very recognizable, but it is interesting to click through and see some of the arrow types and the methods available on objects that we're all familiar with. It is interesting to see it all described in detail in the specification. So TC39, it stands for Technical Committee 39. And that is just the committee, the ECMA International Committee that is responsible for ECMAScript. And this is a somewhat recent screenshot of a panel discussion that they did. These are not all of the members, I don't believe, but some of the TC39 members. And a quote from TC39, ideas for evolving the ECMAScript language are accepted in any form. So TC39 deals with incoming proposals for changes to the specification, and they're more than happy to receive new proposals and ideas, and I'll share with you at the end some ways to submit these types of proposals. So they do have some process, and so I'll just share with you the life cycle of a proposal as it goes through TC39, just to set the stage for the actual proposals that I'll share. So there's stage 0, which is it's not really a stage at all. It's really just any proposal that comes in that gets discussed at a TC39 meeting. They consider this stage 0. This is anything that's just starting to be considered. And the first real stage is the proposal stage, stage 1. And this is where a champion, someone responsible for that particular proposal, outlines the idea, makes a case for it, possibly doing demos. It has happened where someone who's not a member of TC39 makes a proposal and then actually gets invited to the meeting to potentially champion the idea. So that's pretty cool. Stage 2 is a draft. So this is where they start using the specification syntax and semantics to put it into this formal specification language. But it's just a draft, so it's still open to change and debate and considerations. And then stage 3 is the candidate stage. So this is very nearly ready to be implemented. It's pretty stable. Oftentimes stage 3 candidate has been implemented in Node or on certain web browsers, or maybe in Babel as an option. And at this point, they're usually gathering feedback from the implementations that are already out there. And to be at this stage, it's required that all of the ECMAScript editors have signed off on the current spec text. So it should be very close to its final form. And stage 4 is finished. And so this means that it's in its final specification text, and it will likely go out in June with the next ECMAScript specification. It means there's at least 2 implementations already out there, and there is a shared test suite, which I'll also share with you towards the end of this presentation, which is shared between different JavaScript engines. And so there needs to be, this proposal needs to be included in that test suite to be at stage 4. Cool. So that's just a little bit about ECMA International, ECMAScript, and TC39, and the proposal lifecycle. And I just wanted to share a few of the current proposals with you guys in various stages of the lifecycle. Cool. So starting with one that is at stage 4, so it's towards the end. It will likely be included in the next specification. Dynamic import. So this is the ability to import a module with an expression. So it's similar to a function. And so you would no longer be required to have all of your imports at the top of the file. And so the simple benefit is that you don't download code that you don't use. And it works like a function. It works like a function which returns a promise that resolves to the module that you're importing. So it looks like this. And you can see here's the import statement, the dynamic import statement, which returns a promise and resolves. Can you see my cursor, by the way?
Yep.
Yeah. Yep. Cool. So it resolves to returns a promise, which resolves to the module. My impression of this, it's not something I've used personally. My impression is it can be very useful on the front end, but at least in my experience, I don't anticipate a lot of use cases on the back end. So this was my initial response. Like it seems really cool, but personally, I'm working more on the back end, and so I don't know if we'll find a lot of use cases for it there. But I can imagine this being super useful in certain cases on the front end. So I do think it's a good, positive feature. Okay, so another stage 4. So we expect this to be out in the next release cycle of ECMAScript. This is optional chaining. And so this allows you to avoid repeating yourself in the code. It's a pattern where I'll just jump to the code so that we can see. It's a pattern probably many of us are familiar with in JavaScript, where you check if the property exists before you access one of the properties from that one. And it's a little bit ugly. You typically don't like to repeat yourself in the code. And usually it's not necessary to do so, but from my experience, this is actually a quite common pattern. And optional chaining allows you to avoid that without adding any additional risk into the code. So it looks like this. It's just a question mark before accessing the property. And if address does not exist in this case, then it won't throw an exception here because you're trying to access a property of undefined. And so, yeah, I think it's really handy. I'll show you my reaction to this one. Is actually, I really like it. It's available right now in TypeScript. And we've already started using it on our code base, and to me it's cleaner and it's just as readable as well, probably more readable, which of course is a good thing. And you can use it to access methods, array elements, even the delete operator. You can do an optional delete, so if A exists, then delete B. So this was, I thought it was cool that that is included. You can stack it in this fashion. And you can also use it as a way to short circuit. So X will not be incremented if A does not exist. You don't have to worry about this code executing or anything. So that's really cool. I was really happy when we upgraded our version of TypeScript to include optional chaining. Okay, weak refs. So this one's really interesting. It allows you to create a reference to an object, but not a weak reference. And so the garbage collector can destroy that object if it gets to it. And the weak reference allows you to continue to to check if that object exists, and then do one thing or the other, depending if it does. And so it's a nice optimization. This code is probably difficult to understand just in a 30-second look. But you can see here, this is the creation of the weak reference. And then they're setting the results of the weak reference in the cache with a key. And you can see the use of it here. So they take the key and then they get the reference from the cache, and then they try to deref it. And if it's not undefined, okay, then that's great. They return the object. But if it returns undefined, then they just get a fresh version of the object. In this case, it's an image. So they pass in a method to retrieve an image. And then they update the cache and then return that image. And so it can be a really nice optimization if you're having a cache, and maybe it's easier in some cases than dealing with cleaning up the cache or having a time to life on these objects and those sorts of things. So to me, this was my reaction, which is it's a lot of curiosity. I think, I guess you always have to be careful, like using a cache can be tricky, but I think this could be a really useful optimization. So I think we'll definitely look at taking advantage of it in our code base. Okay, so stage 3. So this is nearly in its final form. And yeah, so hopefully getting to stage 4 at some point. And so this is the ability to make fields private within a class. And so it helps to encapsulate behavior. And it's available in TypeScript 3.8. So it looks like this. You just prepend the property or variable that you want to be private with a hashtag. and then you cannot access that from outside the class, only within the class methods. And I think it's very good to have explicit encapsulation like this, because I guess oftentimes you may have the agreement in the code base that you have setters and getter methods, and you don't access the variables within the classes directly. But I guess we've seen in many cases when something's not like enforced and the code base grows and the team grows, sometimes corners get cut. So I think it's a really good thing to be able to explicitly enforce these types of things for a code base. But it's really, really ugly. I think it's not the prettiest implementation. I know I'm sure they had many discussions and this was the best, ended up being the best way to do it, but kind of you look at it and you can't help but sort of not liking how it looks. But I think this is a useful feature. Okay, decorators. This one's earlier in stage 2. So this enables extensibility of class behavior. And so actually I have not used much the TypeScript decorators, but apparently this would implement most of what is available right now in the TypeScript decorators. And it would allow creating new decorators by composing existing ones. And so it just looks like this, or this is one example of how it can look, adding a decorator to a class to log the entry and exit of the method that you've decorated. I'm sure that decorators can be super useful in some situations. I haven't used them extensively in my own experience, but it's not my favorite feature. At least my first reaction is that it seems to add some invisible functionality. In other words, if someone who is new to JavaScript saw some of the behavior, it wouldn't be maybe immediately obvious to that person what was the cause of that behavior. And it could be difficult for a newcomer to track that behavior back. And even though it can be super useful and obvious to someone who's been coding in JavaScript for quite a while, I think it can impact kind of the growth of the language overall when things become more obscure. And I think sometimes when you have a very popular language, these types of things can go unnoticed because the voice of the newcomers is not as loud. But the caveat is that I have not used decorators a whole lot. So that was just my initial reaction. But yeah, they are all Jim Carrey reactions. Cool, so a stage 1, so one that's in the early consideration stage is the pipeline operator. So this is really just syntactic sugar. The best way to explain it is to show the code snippet. And so, so this is really clear, this first line here. It's easy to read, but it's slightly unnatural, right? Because you kind of have to read it from right to left, where you take the string, you double say, then you capitalize, and then you exclaim, which is, it's not a huge deal, but these types of things can add small amounts of friction that add up. And then, yeah, but with the pipeline operator, it allows you to read it in a more natural way by applying the method to the string on the right. So you take hello, double say, and capitalize, then exclaim. So to me, this is, yeah, it's just syntactic sugar, sure, but to me, it's more readable. It's not adding any invisible functionality. For a newcomer, I would imagine that they would quite easily be able to interpret what this code is doing. So actually, I really like it. I think it's a great new feature. Maybe not as excited as Jim Carrey there, but cool. One more is records and tuples. So these are deeply immutable. So a tuple is similar to an array, but deeply immutable. And a record is similar to an object, but deeply immutable. And I think this is a great thing because it's facilitating a more functional programming style. And similar to my previous argument, it's always better to, I think it's nice to be able to enforce these types of things in a code base, and to explicitly say that these are immutable, and see if you can encourage a more functional coding style if that is what you're going for. So it's very simple. You have the prepended hash again, for an example of a record there, and then a tuple. Yeah, this was my reaction because I guess sometimes JavaScript, you have the feeling that in some cases you really have the power to do anything, and sometimes that's not a good thing. And so this allows you to restrict that power a little bit, which can actually be more powerful in the broader sense. And the last one, actually I didn't have time to grab a code snippet for this one, but it's it's stage 1, and it's big decimal. So it allows you to use numbers in a more precise way in JavaScript. So JavaScript has certain rounding errors that can be a big problem if you're doing something with, say, currency. I've worked in a code base where we did everything in cents instead of whole dollars, just to avoid these kind of rounding errors. But that is another example of creating small friction in the code base because we're not used to thinking in cents, and then you have to kind of always convert when you're reading the code. It would be more convenient to use whole dollars. For me, this could, it is, I'm sure, already a library, and I think maybe it's more appropriate as a library, in my opinion. I'm not a huge fan of just continuing to enlarge the language, but yeah, maybe there are some arguments that I'm not aware of in favor of this proposal. So yeah, that's the end of the proposals. I wanted to share a few suggestions on ways to get involved in this process. These ways are less direct than just joining into the TC39 technical committee discussions, which is not so easy. But I think these are really great ways to have an impact and get our voices heard, and probably learn quite a bit along the way if you do take the time. So in the GitHub, you can refine proposals via comments or pull requests. That test suite that I talked about earlier, this is the link to it here. This is the central test suite shared by various JavaScript engines, and you can get involved and write tests for the new proposals that are coming out. You can implement new proposals in projects like Babel or TypeScript, or any of these other transpilers or libraries. And then there's this link here, which is a Discord group where people bring like stage 0 straw person proposals and just discuss JavaScript and ECMAScript in general. So that's probably a really good place to get started and have a look at the discussion, share ideas. I think like TC39 and the broader community, from some of the talks I heard, are making a really big effort to become more inclusive in terms of how they evolve the language and have these discussions, and not create the impression that it's sort of a closed door group with like the big browser companies making the decisions behind closed doors, and try to get the community more and more involved, because that's the best thing for the language. And because there's that sentiment within that core group in TC39, I think it's a better time than ever to get involved, because I think there's a lot of encouragement coming from within. So yeah. Oh yeah, attending, as I said, it's not so easy to attend the TC39 meetings. Members are actually organizations, and the Apples and Googles, and then they also can invite experts on on certain proposals or these types of things. So it's not as easy to attend the meetings, but they do post the transcript from all of their meetings on GitHub. And I have a link at the very end of this slide deck for that. Daniela Carvalho, she's actually a coworker of mine. And when I mentioned this subject for the talk, she had literally given probably a better version of the same subject some time back. And so she was super helpful giving me some advice on this subject. And her slides are there. And many of you may know her because she's been involved in this meetup. And then Daniel is a member of TC39, and he has a really good talk, a speech that he gave at a convention, of which the link is there. So those were just two particular resources where I got a lot of inspiration from. And yeah, this is some additional references, and that's, I don't know if there's any questions, but that's it for me.
Thank you, Tony. We have some more of comments than questions. So regarding the private methods, someone mentioned, why not just call it private? Like we already have static, for example. Do you want to comment on that? That was actually my first thought. Why
actually, you know, it sounds like extremely obvious now that it was mentioned to me, but I hadn't thought of that, and that makes to me way more sense. I'm not sure why they wouldn't have gone with that.
Yeah, there's also a comment saying that some of these proposals feels like we're removing the script out of JavaScript so that we are left with just Java, which like all this investment in classes feels like.
Yeah, I completely agree. I think to me it's not, sometimes it feels like when there's something that's successful and going well and there's groups associated with it, there's this tendency to think, okay, what's the next thing to add? What's the next thing to add? Maybe it's not always, sometimes it's refining is better than adding. So yeah, I really agree with that idea.
Mm-hmm. Just one last comment regarding decorators. Conrado is saying that they're useful for inversion of control and dependency injection. Do you want to comment anything on that, or?
No, maybe you have a comment on that.
All right.
No.
There's another question from William Ribeiro. Have you ever attended the TC39 meeting? If so, how was it?
No, I have not. That would be really cool. But yeah, I don't think it's so easy to attend.
All right. Thank you, Tony. We could, now it's the time that people clap to thank you, but in a webinar, it's just weird people clapping at home. Thank you so much. João, would you like to start?
Yes.
Oh, actually people can clap in the chat.
Oh, cool.
Yeah, I didn't thought about this first time webinar.
Nice.
Sorry, Tony, can you stop sharing your screen so I can?
Yes.
Thank you. Okay, let me just put this on.
All right.
Let me just move this from Zoom to another place. Okay, can you see my screen?
Yeah.
Yeah, nice. Okay, so I will start. So hi, everyone. First of all, thank you a lot for this invitation to talk a little bit about the Vega ecosystem for data visualization here, mainly for a web development context. I'm João Palmeiro. Currently, I'm doing my master thesis at Feedzai. I'm a research intern, and for this specific talk, I would like to start by framing it a little bit, because I think there are a couple of considerations that are worth mentioning in the beginning to manage somehow the expectations and the things that I will try to cover. Then we'll talk about Vega, what is Vega, and how we can use Vega for data visualization, and why I was starting to call it as an ecosystem. Then we'll see some examples and some snippets of code. Then I will talk about my experience last summer during some internship that I was doing at Feedzai as well, where we started a sharding library using Vega and other technologies. And I would like to finish the talk giving you like the possible links and possible materials so you could manage to get to the next level in this technology if you feel that it could be useful for you as well. So first of all, I will try to introduce Vega and the specific ecosystem for data visualization, and I will solely base on my personal experience. So this is not like a tutorial or a talk that I will try to cover all the pros, the cons, how to use it in different contexts with different frameworks and whatsoever. I will try to introduce you the topic, the technology, and then I will try to convey to you my personal experience and why I did like so much using it. So for this talk specific as well, I will try to cover like data visualization in a more pragmatic way for web development. So we will not be discussing like this is a good chart, this is a bad chart, should we truncate the y-axis or not, and this kind of more theoretical questions on data visualization. We'll try to go just with the more practical and the more and with the code for doing some visualization and abstract this is a little bit. So I hope that by the end of this talk, you somehow will be able to describe this ecosystem, this technology, and will also identify it as an interesting alternative, both for your work and at your companies, at your startup, whatsoever, or for personal projects where you want to create some web apps or want to do some data analysis and so on. So this is basically the main website, and you can already start to grasp some of the major things, like it describes it as a visualization grammar. You have a lot of building blocks. It also has different APIs and so on. So basically, and here I will try to start with Vega, like the main toolkit of this ecosystem, and it's basically a declarative language for creating shards. What I'm trying to say with this declarative adjective is that in a sense, you can use this same language for the static and the iterative part. So you declaratively declare all the things that you want on your chart, and you are not concerned how these things will be implemented in the backend. And basically, you describe your chart in a JSON format that is widely used for a bunch of different things. Here you'll put all your things for your chart here in a hierarchical way. So you somehow separate the specification, what your chart should look like, from how I will need to code or to approach to concretize this specific chart. This is not the concern that we'll try to cover. This is not the concern that Vega tries to. That's the concern that Vega tries to keep you out. He has a nice backend. He has a functional reactive backend, a couple of nice things that they do to have a performant technology. But today we'll try to focus on this part of the specification. And to finish this part, it is based on this book from Wilkinson. Is the Grammar of Graphics, in this kind of a Bible for building blocks for data visualization. So just to give you an heads up on this, if you are not familiar with. So basically, this is a kind of way to describe any chart using different building blocks that each one of them have some meaning, and you try to pick the most useful ones to build your visualization. You try to do like this kind of mental map to achieve the visualization. So you start with data, of course. Then we have the transform part. It's basically filtering, aggregations, and this kind of transformations on the data. And then you start to think more in the visual primitives for your chart. So you have the marks. This is basically the representative elements of your data. So the bars for the bar chart, the points for the scatter plot, and whatsoever. Then you start to think in the encoding. It's basically, okay, let me map my features, my columns, my attributes, the things that I have in my my data set, and I will map this to mark properties to check different things. You have the scales that are basically the functions that will map your data values in the human domain, let's call it in this way, to visual values that are basically pixel based. And then you can also think on guides to help you visualize the scales and complement this, and giving a kind of more semantic meaning to the points or bars that you are trying to see. So basically, there are different nomenclatures for this. This is not exactly the one that is in the book. It's one that is more used to describe this ecosystem, but there are some differences. But what is important here is it is a kind of foundation for creating any chart. And you can use like these building blocks to create any kind of chart. So continue with Vega. It's low level, but not as much as these three. I'm not sure if you know these three. That was the moment that I would start to ask for you to raise your hands and whatsoever. But I will assume that that you somehow have at least an idea what D3 is, and it's basically like one of the most known visualization libraries, and I'm calling it library. Maybe it's not so correct, but just to keep it simple. And in here you can go like super low level and play with SVGs and SVG paths and the groups and that kind of stuff. I think you can create almost everything with it. Vega is strongly backed up by research in academia, and I think it is a very interesting point, because if you look to their website, you have a couple of papers, a couple of works, and they, starting from 2005, they are there's some people that are here from the beginning, but somehow they are trying to step by step concretize a very powerful way to do data visualization and to do good data visualization with less effort possible. So it is in constant development. It's a good thing. It has already a noteworthy community. It's not like the biggest community or the most active community in the world, or the one that shares a lot of different charts with different variations, so you can learn a lot from every place basically. But you have a really nice community, approachable, and you can learn a lot using the things that other people built. And this is kind of the punchline to introduce this, is that one of the things that I think highlights Vega regarding other visualization libraries, framework specific or not, for web development, for data science, it doesn't matter here, is that it has like this central motivation. One of its core motivation is to serve as a foundation for high-level tools. And that's why I introduced it as an ecosystem. So, of course, in the ecosystem, you have Vega itself. You can use Vega. It's more low level, but you can use it as well. And then you have this kind of high-level language built on top of it, and it's called Vega-Lite, and and we'll try to cover it a little bit further after a couple of slides. But basically, it tries to help you quickly build the visualizations and different variations of the visualization that you might want to see, but in a more high-level fashion. Also, you have Altair, it's basically a Python API, but on top of Vega-Lite. You have Elm Vec. It's a package that you can use using functional programming in Elm. You have one wrapper as well for Julia. You can use it on Flourish. That's basically a kind of Tableau online that you can use to create really awesome data visualizations, but more in a click and drag style than instead of coding. And you also have these kind of recent platforms, recent works that try to leverage as well the in this case Vega, basically having it as a way to show code that you can run using WebAssembly and a Python interpreter, and you can have it rendered in Vega-Lite quite easily. So there are also people that are using it to build nice tools. So focusing now on Vega-Lite in specific, it's declarative as well, and now we'll start to see the differences. I'm not sure if difference is the best word to describe this, but I will use it because in a way you'll not be doing like a lot of different things, or the backend will not be different. You'll just have a way to do some specific things in a more high-level fashion, like the things that you usually do for a super simple bar chart, like position your elements, put some color and so on. So basically Vega-Lite comes in and says, okay, you already can do this basic thing very easily in a JSON specification. You can do a lot of more things like interaction and multi-view charts as well, but you have to put more work on it. So Vega-Lite comes in, okay, I have a way to do it more easily with this grammar of interaction. That's basically, they basically introduce a new building block, selections for you to quickly program your interactivity on your charts, but take it with a pinch of salt, because I'm saying that it's more easier, it's super high level, it's super easy to use and whatsoever. But if you start if you need to do some a couple of things that are more complex and that are not so like, let me highlight this bar versus the rest of the others, let me highlight this area versus the rest of the other areas. If you want to program like a really complex interactions, depending on a lot of heuristics or variables and whatsoever, it will be more tough. So I'm saying this, but please take it with a pinch of salt. There's a learning curve here as well. And also you have this very nice composition algebra. So basically it's a way that you start with the basic unit for a chart is like, let's call it a unit view in Vega-Lite. It's a basic chart, a basic bar chart. But for example, you want to put some labels on top of the bar to visualize the absolute values. Maybe it's a thing that you want to convey as well, just like a relative comparison, but also, oh, this is the absolute value, because it's important as well. You can just layer one chart on top of the other and basically came up with this combination of a chart that uses text to plot data and versus one that uses bars, and also multi-view charts that are a kind of simple dashboards, let's call it in this way. And as I said, is quite powerful as well. Things are simpler than in Vega, and for many things you'll not feel that it's too much high level, or you'll need to do some workarounds to have some specific things done. But as I said, there's still a learning curve to use it at full power, at full scale. So let's start now to see some code. I think it's the most interesting part. And for this part, I will try to go step by step, constructing a specification that will, in the end, originate this very specific chart here. That's basically the top 10 sectors with payment operations in Lisbon during the last months. And this data was took from SIBS Analytics. And basically, you can just approach it. You have a tooltip. You can see that catering service and restaurants, the amount of money that are being spent, it's not so much. It's expectable. You have like this huge bar for the supermarkets. And this is maybe just the start of analysis that you want to do. Is just a kind of plot that you want to have in your application, so for people to easily get a sense of some specific data. And in the end, it's just a bar chart that we'll try to construct here. So first of all, and here I know this, I introduced it very quickly, and if you are not used to use the grammar of graphics to construct data visualization, if you are not used to construct data visualization in your daily jobs on your side projects, maybe I will ask you a tough thing, but please try to remember of the list that I said earlier and see how we will construct this chart. So first of all, we declare the data. Our data set is in a CSV file, sorry, and no chart at all. I think it makes sense because we just declared the data. We are not mapping anything of our data to any visual element. So a blank screen. Then let's start to define our mark. And basically, in this case, since we want a bar chart, we want a mark that is of this type, bar, and we put it a color that we can choose easily. But that's all the things that we put it here, and basically managed to create this squared blob that does convey anything. Like I said, I think this also makes sense because we are just saying that we want bars, but we are not yet writing any specific information for Vega or Vega-Lite know how they should construct the bars. Where is the to what data should I look to construct the bars that you want to check? Then you start the encoding part. And this encoding part, it's where you try to map your attributes, your features, your columns in your data set to specific positions. You can also to specific colors, to specific shapes, to specific orderings, etc. So basically, what we have here is, okay, for the X, basically the X-axis, I want to show in a categorical fashion this column that's called emojis is basically the category, the sectors in this data set. And I will also provide some guides for people to easily match these bars with my data. And basically I want an axis with this title sector, and label angle is just to put it, is just to, for this information here not to be rotated. Then we add a second encoding and things start to show up. Basically, okay, I already put in terms of position, my bars for each one of my categories, like here, and then I'm saying, okay, so for the y-axis, basically the length of the bars, look at the amount of euros that were spent in Lisbon. This is a quantitative variable type because it's a continuous variable, it's money. I think it's common sense. And also for the axis, the guide to help people interpret these bars. I want this title with the unit, and also I want this format. This format maybe looks a little bit odd, but it's basically following a library of the D3 ecosystem, D3 format, and this is basically saying that, okay, I want, instead of having a huge number here, round it, put an M because of millions, and I want to decimal cases. Then we can sort it. We go back to, sorry, we don't go back. So please look at, this is I didn't highlight this yet, but I think this is important now. Look at the hierarchy here. So basically we have the encodings, one position, another position, and now I just say, I'm just saying, okay, this sort. But what is sort? I think maybe it's an odd question to ask, but basically it's just like a different property that you want to see in the way that your data is positioned. So it makes sense in hierarchical terms, sorry. It's inside of the X position because you want to order the things that are in your x-axis. Finally, or not so finally, sorry. You'll start that idea of layering things up. So basically, layering here is just, okay, I have a chart, a basic chart, but I want to add information. And for this information to be on the right place, like these numbers, how should I should program this? Well, in this declarative way, you'll not try to see, okay, let me see where is this position and put it a little bit further, and that kind of more imperative way to do this. You are not concerned about that. You just, okay, maybe this text is just another chart where the position will be on top of the bar, and you could omit the bar from here because you, again, you can go and pick your amount field to put it on the correct position, and you end up with one label for each bar here. Just a couple of remarks from here. We also have our mark. We have in a different position of this list, we have the text. This offset is just to put it a little bit further from the limit, and then you program it quite similar as we have done. And now finally we can just easily say, okay, I want a tooltip as well. Maybe this is not the most grammar of graphics based thing, but it's a nice addition for you to easily add this kind of information, maybe that are not so important at the first glance, but for an analysis, a bit more careful analysis, it's nice to have more information. So here, basically, maybe these emojis are not clear at all. They are nice because in terms of space, they are super small. Some of them are quite easily to grasp, but maybe you are not sure what these bags could mean. You can just go and check that. Okay, this is consumer goods, nice. And I was telling lies, sorry. I forget about the selection part. And this selection part is basically the interaction. And what type of interaction could we have here? Like, okay, let's consider just a simple one. We click on the bar, and for example, you can see here anything like, okay, let me do some logic to handling this event that people clicked in. No, you are not concerned on this here. In Vega, but also here you can customize it. For example, in Vega-Lite, you can, okay, instead of the click, I want a mouse over, and you can easily add here a new field. In Vega, you can go a little bit further on that. But like I said, declarative, I just want a selection, a multi of type multi, because I want to press my control button. That's and this is a default button. I can highlight 4 bars, one just now, and basically I'm saying, okay, but I want to select and I want to highlight. What kind of thing is this in terms of visual primitives? Basically, it's again instead of encoding. Okay, this is just the opacity associated with the color, and then we write a condition in the format of if then else. Okay, condition, if the bar is selected, the value is 1, full opacity, if not, 0.3. And by default, and you can see that it uses a lot of defaults, so you can quickly have a nice thing to use, but you can dig into it and customize a lot of things, but it provides a lot of defaults, and you quickly have this chart that you can align bars. Okay, I'm not sure if there are questions or not so far, but I will continue. Maybe in the end, if you want to, if you need, I can go back to these slides and explain with more detail. But basically now we have this bar chart with highlight, with tooltips. We also have this button that I'll talk about later that you can download it as an image, titles that I didn't show it here, but it's basically a more configure. It's a thing that you add to your JSON specification that you can configure your title, your subtitles, and other configurations that can work like a theme for your chart. And I think this is really nice to quickly have a super interactive chart. Okay, but this is not. Sorry, yeah. This is not the end. You can do like a lot of different things here. One more for analysis, one more for leisure, for example. This chart from Florence Nightingale is basically one of the, let's call it, main historical data visualization that people usually show in these kinds of moments. That, like, I'm working on data visualization as well, and we don't see a lot of talks, at least here in Lisbon, on this. So we somehow sometimes we end up, okay, let me show these things that I really like, and people will start to see them as well. And here, what I will show you is basically, maybe can we implement this rows chart, this kind of pie chart, but where the segments have different areas to convey this information about mortality between 8054 and 8056. I think it's quite possible. Like, we have the title, the subtitles, a more recent style for the colors and the typefaces and so on. Some things by default are not great, but for example, these labels here, some are not. They are not super flex, so we can see the letters like in a way follow the curvature of each of the specific segments. But by default, we can achieve a pretty nice thing. Different colors. We specify the ordering of this bar of the different segments. Basically, each color is a different cause of mortality, and also using like a thing that I already showed. In this case, it's not a layer because we have basically a chart side by chart, but it's a similar thing that is called facets. That's basically, okay, I have a variable, and this variable have different categorical values, for example, and I want to see a graph for each one. You could like also, okay, let me programmatically do first for this, then for this categorical value, then for that. Here, you just specify, okay, this is for this field, and move on. You just like are more concerned in programming the unit view, like this, each of one of these charts, and does the rest of the work for you. But also, if you can see, for example, here on this segment, we see a no, this one, I think. Yes, this one here is pink, is majorly pink, and you have this blue part. But here you can see that it's not so correct. Like, okay, we have the blue part here, but you have the black part that it's almost the same as the pink part. That's this short. curvature here. And basically, since I used the defaults to, okay, I want this ordering based on the max value. So okay, this will be drawn here, and then the next one will be this pink one, and then will be this black one. But maybe here you would like to highlight a different one because they are almost the same, and the black color is for other causes of mortality that maybe you are not so concerned. And here is where you start to need to explore more and more of Vega-Lite and Vega, because in this kind of problem that you want, okay, I want a specific behavior for this part, where it starts to, you need to start to go through the learning curve and try to see if it's possible or not, go to Vega or not. Well, I think everything is possible in terms of programming this kind of things. Maybe some are more beautiful than others, but here you are moving from this kind of philosophy that I introduced you, that is everything easy, quick. You have not to bother at all. The things that are not so simple. And finally, another plot. Here, basically, we are seeing the top 10 registered first names by gender in Portugal in 2017. And you can see, again, this is not phased like the other. This is basically concatenated. Like I designed this chart, then I designed this one, and I put them side by side. And you could do with this a couple of charts, and you'll end up with a kind of dashboard, simple dashboard. And here, basically, instead of a bar, you are using 2 marks as well. Again, 1 mark for this kind of rule, this line here, and then you put a dot or a point or a circle at the end of it, so people can read somehow the value. This is a lollipop chart. Is an alternative to horizontal bar chart, but here I just picked it to show you that you can combine different marks, you can combine different scenes, different types of charts, and came up with a really nice visualization to show a specific thing. Also, as I said, since this is a chart and this is another kind of independent charts, you can also, okay, for this, I want to abbreviate my labels on the x-axis, but here not, because the values are more uniform distributed, for example. So, having said this and introducing you Vega and Vega-Lite as a way to do data visualization in a web development context, I would like to talk a bit about my experience last summer at Feedzai in a summer internship, where we kicked off basically a Feedzai charting library. And the motivation for this, for a specific company, a specific team, specific people trying to come up with a in-house library, or at least try to have an in-house library for data visualization. It's basically because there were no standards for designing visualizations, like for those that know the concept of, for example, design systems or brand guidelines. This is kind of the same thing, but for charts. Reproducibility in the sense, okay, so basically we have here an ecosystem. We can use it in different technologies. Okay, some are working better than the others, different paces in terms of development and updating. But maybe, okay, we have these people that do data science with Python. We can use Altair. People that program for the web can use Vega or Vega-Lite. Maybe we can somehow having a way to have charts in a reproducible way. And also because the chart, it's a specification, it's a JSON. It's basically a bunch of text, hierarchically structured, and will, for most of the cases, it will render exactly the same. If you are doing, if you are using Python, or if you are using Vega or Vega-Lite. And also because we were using different libraries for Feedzai's products. So maybe this kind of standardization and having the people bet on a specific library could be a good thing as well. So the approach was basically, okay, we already have this React UI component library. Maybe we can expand it. So using the library that the people in the front end already uses, maybe you can have also some charts that people can use as well, like in a similar style. But for this, we needed to combine React and Vega. And for that, there were no like practical no examples how to do it, if there are things that we should pay attention or not. Because here in this talk, I'm not go to the foundations in terms of logic and backend and how the Vega API works and that kind of stuff. Like how we end up from a JSON specification having a chart embedded in our web app, for example. But maybe we can we should pay attention to these specificities between different technologies. And since that there were no examples, and this library, this React Vega library, offered no advantage, it's quite it was basically a wrapper to more easily embed visualizations as a component from the JSON specification. We ended up put a lot of thought on this. And it also contributes to the idea, okay, maybe instead of developing a lot of different charts that people can use, no, let's focus on a specific component, on an end-to-end histogram in this case, and let's do it like full power with all the things, like a full test suite. Let's integrate it in the place that it should mainly work. Let's see how we can manage, first of all, combine these two technologies and have a available or not option to do data visualization on the web. So basically, this histogram was a histogram that we want to be like full pledge of options to customize it, like throw a React component. So think about props that people can pass to the component, and then we'll end up with the JSON specification that will be rendered. But and for this, we wanted to have like this full powered histogram that can do a lot of things. So it can substitute the one that is currently being used, or that the ones that are currently being used, and also offer some out of the box some advantages. So for this histogram, we wanted a basic histogram for a single distribution. Of course, a layered histogram for two distributions is also important. We want to customize the labels of the legend as we want. We want to use different scales, like different map functions between our data values and the things that we see on the screen. Okay, we want linear scales, but we also want to have the option to use a different function for the vertical axis, a customized tooltip to show all the details in a structured fashion. Also, for example, in the case of the layered histogram, we want the legend to be interactive, and we can select one distribution to see towards the other, and that kind of interactivity and manipulation of the chart that we are seeing to discover new things. We want our axis to be kind of intelligent in the way that they deal with labels, and Vega provides a really nice way to do this. Basically, if you have a lot of, if for example you have a small chart, and you have a lot of labels, by default they will cut some of them, and you'll just see like from X to X interval by default. We have a button so people can save the chart as an image, as an SVG file as well, and that kind of stuff. We want to put a threshold marker so people can have a reference value. So like a simple histogram, but in the end with different things that we needed to implement and different like passes of on this kind of tree until we achieve the histogram to render on a specific place. For this, we besides React and Vega, we use mainly these five libraries. Yeah, let's call it libraries in our stack. Like Vega embed, it's like a wrapper that you can use where you can pass your specification, some options, and you'll have the component rendered on place. And that's the one responsible for that button that I clicked previously. Just an example for the tests, Lodash to check some things on the React component, and Storybook to have a way to show it easily. Because it's a chart, it's super visual. Storybook helps a lot to do this. So we end up like with a typical folder structure for a React component, but with a new folder for the JSON specifications. And we kind of separated the concerns between the histogram and between the component and the data that it receives and the basic Vega specification that is in a JSON. What I'm trying to say with this is that one of the responsibilities of the histogram was basically to adapt and customize the basic specification according to the things that it received as props. And we also use, for example, refs to facilitate identification of the container, because it is first rendered like a empty div, and the chart will appear later. And it's basically like the kind of skeleton that you followed for the component, that you called it like lifecycle methods wrapping. So basically, first of all, we have the constructor. Of course, in the end, we have the render that returns just a div. And to try to separate the things that are more Vega specific than from the ones that are more React specific, we try to map this out as a kind of internal API, in the sense of, okay, we have the lifecycle methods to do a couple of things. And since we used Vega for some things, we went a little bit further in terms of using directly the API for some updates, for example. And we ended up having these functions that we'll later call other functions to rebuild some specific parts of the JSON specification. In the end, Vega embed received the final specification for being embedded on this div. Like I said previously, the histogram component already received the processed data. So data that is just the only thing that's need to be done is to visualize it. And this is also a thing that I would highlight to you for here, because okay, Vega is a well-defined data model. It's like a tabular model or a record-based model, if you think more in a JSON fashion. But here, the more important thing here is, okay, we have this component responsible for showing this specific chart. We have the specification. Okay, like you said, in the grammar of graphics, you have a transformation part, but in the real world, with big data, with a lot of pre-computation that is needed until we reach the data that is needed to be checked, maybe this is not that's not a concern for the histogram component or for Vega or Vega-Lite. Maybe we should do this with different technology in the different place, do some abstraction, and these kind of things will only receive the data. I think this is one of the most important parts, is to sit a little bit and see, okay, where is my data? What needs to be done before we need to visualize it? And how should I separate the different things here? But not all the things are good. I think there are a couple of cons, and the ones that we identified based on this work were these three things that we would really like to see completed, and that are on the roadmap, but yet they are not implemented. So animations, in Vega, Vega-Lite, Altair, whatsoever, there are no animations. We can do some basic things with CSS animations because each part of, or not each part, but some specific parts have a specific class by default, you can specify a name for it, so you can access them easily in your CSS, and you can like put some animation for the entry of the plot or that kind of stuff. But it's not the thing that we are really concerned. Maybe animation it's particularly useful in my opinion where you want to change between, for example, the distribution that you're seeing on your current chart and these kind of things. And if the changes are super small, maybe you will not grasp it. But maybe in an animation, you'll see where the change will occur. And I think it's a very nice thing to have on this kind of charts. We want also wanted to see the improved React support through that library that I previously mentioned, some other specific ways. Maybe the thing that we felt that, okay, there is not like proof of concepts to do this in a good way. We have done this in this way. Maybe we are doing some mistakes. Maybe we can optimize some things, but in the end, there are not really some things to compare with. And also smart labeling to have labels on the data. And I previously showed how to put like the text on top of the bars. And what I'm trying to convey here is having this, but in a more smartish fashion, in the sense if, for example, if you have a scatter plot with a lot of points, and maybe you want to highlight some in a small cluster, but maybe if you plot it by default, you'll end up with all points together, and it's basically visual clutter, and you can't really see the labels. But maybe if in the backend you have some smart algorithm to do this, it could be nice. So the next steps in this case, the things that I want to finish this presentation that I want to give to you, it's basically a couple of links that you can follow and enrich your knowledge on Vega-Lite and data visualization. We have this blog post that covers a bit of the things that I said now, but some more specific things. The Vega-Lite paper is also a very nice, more theoretical way to understand the technology. We have a bunch of examples. Here you can see like a basic HTML file, and you can put the JSON specification because we were not concerned a lot with this here. There are also this React and Vega dem. That's basically a React component that is a wrapper that will receive a JSON specification and will render it. There are also some nice capabilities, like there's a nice way to stream data to your Vega. There's a nice way to stream data, and the plot will automatically update. And this course from University of Washington has a lot of good material and examples in Altair or in Vega. So thanks a lot for this opportunity, for this talk. And sorry if I took a bit of time to convey everything. So I hope it was useful for you, and you can use Vega or Vega-Lite to do some nice visualizations.
Thanks, João. It was really good and interesting. It's a really comprehensive framework, Vega. I didn't know about it. We have a couple of questions. Does Vega provide some kind of JSON schema for validating the graph's JSON, so the data?
Yes. Yes, basically, the first thing that you put on top of your Vega specification, it's a field that is called schema. It's basically, you will check the things that you are writing on your Vega specification according to a version of Vega or Vega-Lite. I'm not sure if this is the type of things that you are concerned or not, but yeah, it's a kind of semantic validation that a schema does for you.
Cool. Are there any built-in geographic capabilities for plotting data on a map? So when you're working with geographic representations, how does it
Yes.
work?
Yeah, there are also that part are, if you want to check on the documentation, for example, in Vega-Lite, it's mainly the part that are concerned with projections. There are a couple of things that you can do more in a static fashion. Like you can, for example, you have the map of you have the shape of the United States. You want to see a choropleth map, like the states with, I don't know, that consumes more beer or less beer, this kind of maps. Yeah, it works pretty nice in my opinion. But if you want things that you want with a lot of interaction, if you want to build tile layers on top of the map, if you want to have this kind of interactivity more specific in maps and geovisualization, I think there's Vega and Vega-Lite, it's not the most useful tool, I would say. Maybe we want to use leaflets or that kind of stuff. So it really depends what we are trying to do, I would say. There are some capabilities, but it's not a full powered geovisualization library as well.
Cool. Does Vega support more advanced interactions with the graph? For instance, a way to change sorting mechanisms?
Yes. Let me think just a bit. So basically, the sorting mechanism, you can like parameterize it. Well, there is not only way to do it. The short answer is yes. You can do it. There are you can add some widgets. For example, Alter has a nice support on this for Python. It shows you can by setting some specific things, having like a buttons or sliders to do that kind of stuff. But I think that the most useful answer for now is that yes, you can parameterize your specification, so you can have this kind of things.
Cool. Last question. Is there an integration for Vega with Angular? Do you know about it?
I'm wrong. I think that there are, I already saw some experiments at least. For as far as I know, I only know a nice integration with Vue in terms of frameworks. There's some people doing a nice work, and there's a nice way to use it in terms of these major frameworks for web development. For Angular, there are some things, and I think on if you go to the documentation of Vega-Lite, we have like in your navbar you have a ecosystem button. You can click. I'm not sure. I think there are some things for Angular, but I'm at least in as far as I know, it's not like the most robust thing, and I'm not sure if it's really ready to be used. In which version of Vig or Vega-Lite is used, because these things are being developed in different paces. So I'm not really sure if it's the best option is to go with a thing that someone developed, or just try to integrate Vega in your Angular web app.
Awesome. Thank you. All right. Once again, thanks to both our speakers. It was really good. And I hope everyone will have a great weekend, and see you all.
Thank you, guys. Have a nice weekend.
Thanks,
Bye.
everyone. Keep safe.
There's some messages. Right, thank you. Thank you. Awesome. I think that went well.
Yeah, that was awesome.
All right. We should probably end it.
Yeah.
Thanks again, Tony. Thanks, Dashlane. And see you
Thank
on
you.
the next webinar.
Have a good weekend. Bye.
You too.
You too. Bye.